ladies and gentlemen, we're going to explore functional groups. And down here we have our second activity for today. For each indicated atom, give the following hybridization. A, B, C, D, E. I can just put them underneath the labels, huh? That carbon has 4 sigma bonds, 0 lone pairs. That's all you're counting, everybody. The sigma bonds count. Sigma bonds 1, 2 lone pairs. Okay. So 4 sigma plus 0 LP equals 4. Final answer, sp3. So we're going to do A down there. Ladies and gentlemen, that nitrogen, you need more information. That there's something missing. Yeah, I didn't draw Lewis structures here. You can clearly tell I didn't because look, these aren't Lewis structures here either, are they? Look, CH2, CH3. I'm not seeing bonds. This is a condensed stuff, so lone pairs are missing. You better put them on. You're going to get wrong answers if you don't put them on. Let's do all the lone pairs that we have to right now. What about in part C? How many lone pairs on that O? 2. That's oxygen's nature. 2 bonds, 2 lone pairs. We got to know it forever. Carbon doesn't have lone pairs. If you want, I mean, it's not really for this question, but bromine has 3 lone pairs. Oxygen has 2. Nitrogen has 1. You better put that pair there. Oxygen has 2. There you go. Now you're ready to do B. 3 sigma plus 1 LP equals 4. Equals sp3, like you said. Smooth sailing so far. 2 sigma, 2 LP equals 4. You're going to think the only hybridization in this course is sp3, aren't you? You are incorrect, sir. D, 3 sigma, 0 LP. Answer's not 4. What's your hybridization? sp2. There are 3 things in the name. Do you see that? Yeah. H, 1 sigma. No, 2 sigma. How do you know there's 2 sigma? Are both of these sigma? Are both of these sigma? No. 1 sigma, the other is pi. 1 sigma, 2 sigma. There's an H there, right? 2 sigma. Yeah, if you don't see the bond, doesn't mean it's not there. And H has to have a bond. 2 sigma plus 1 LP. What do you got? 3. What's your hybridization? sp2. 3 sigma for the carbon here. One of the sigmas is the H. The other is the first bond to N. The third sigma is the bond to C. And there's no LP. Yeah, we're on an sp2 kick right now, aren't we? The sp2 kick ends right now. That was G. Just a reminder, that was G. F, 2 sigma plus 0 LP equals 2. What's your hybridization? 2 fingers in the air. ST. Want to make sure it's clear what we're talking about here. That's for F. G is here. H is here. And E, 2 sigma, 2 LP, 2 sigma, LP, 4. What's your answer? sp3. Highlighter, circle, gray, gray. That's all for E. That wasn't too bad. Geometry, name, and bond angle. Oh, we're going to have most of our names and bond angles here. That's good. Be a good review page. Yes, sir.
Is a triple bond?
A sigma and 2 pi's is a better way to say it, but I'll accept triple bond. Yeah. A double bond is the sigma and a pi. That's a better way to say it, because when you say double, they sound the same. They are nowhere near the same. Did you know a pi is only 60% as strong as a sigma? Because the orbital overlap is not direct, it's above and below. Those p orbitals are above and below, right? P makes what? P makes pi. Those orbitals are not directly between the atoms, they're above and below. That's not as good. So we're going to do the answer for part 2 down here in blue, 2 blue. sp3, 4 atoms attached. No lone pairs. What do you got? What's the name? What's the angle? 109.5. What about nitrogen though? It's not tetrahedral. I'll tell you though, the angle's the same. Why? Every sp3 atom, I don't need to keep writing 3, do I? Every sp3 atom is 109.5. Every sp2 atom is 120. Every sp is 180. Every sp3 is 109.5. There's our 3 angles. They're all on the page. It's a comprehensive review of our geometry right here. Names for tetrahedral, 109.5 with 1 lone pair. It pushes the atoms down that lone pair. It's not like it's not important, but it's invisible. If it wasn't there, it would be flat. But it pushes those atoms down. What do you call it? No, trigonal planar is this one here, since you brought it up. Say it again. Bent is here. Look at it. It's bent. Right there. Describe what you see. It's bent. That's not bent because there's an H up here. That's trigonal planar. Yeah. So pyramidal. When do you have pyramidal? 3 sigma, 1 lone pair on an sp3 atom. 3 sigma, 1 lone pair on an sp3 atom gives pyramidal. When do you have tetrahedral? 4 sigma, no lone pair on an sp3 atom. When do you have bent? Oh, that's not here. Oh, this is bent. Coincidentally, this, which was the labeling for up here, and I have the CH2, CH3 circled by mistake, but is the same as here. So when is the bent situation? 2 sigmas, 2 lone pairs. Yeah. And what about, this one. Here's your nitrogen. Here's your hydrogen. Here's your lone pair. Guys, that's bent. Seriously. It's just bent. I'm going to write also bent. There's 2 types of bent. It's just a bent with a different angle, right? Because it's sp2 with 2 sigmas and a lone pair, as opposed to sp3 with 2 sigmas and 2 lone pairs. The angle just shrinks because there's more things around the oxygen than there is the nitrogen. And we did F, but we didn't write the name of the geometry for F. That's straight to the left, and this is straight to the right. What do you call it? Linear. So do we have angles and geometries for all of them? A, B, C, D. Where do you go? don't even see E anymore. Oh, it's up there. E, yes. F, yes. H, yes. Nice. Done. Oh, functional groups. I didn't even see that till now. The functional groups present in each molecule. No functional groups in the first one. You can call them halogens. Sure. This you have to learn is called a primary amine. And I want to make this a good review for the future, right? So here's a secondary amine. What does this thing have two of that the first one didn't have two of? Sorry? Say it again. Carbon. Bonds to carbon. In fact, this could be CH2, CH3 if you want. It doesn't change anything. How many bonds does the nitrogen have to carbon? 2. What's the category of amine? Secondary. 2. How many bonds does this nitrogen have to carbon? 1. What's the category? Primary. Okay. So, 2 C's attached to N. That's where the 2 comes from. Now, when I say this one is a primary alcohol, don't tell me it's because the O has 1 bond to C. Because under that system, every alcohol is primary and there's no need for a system. If you're an alcohol, you told me earlier it's OH, right? Bonded to AC, right? Can't be 2 C's. That's not the way O bonds. It's always going to be 1 C. Nitrogen can bond to 0 C's, 1 C, 2 C's, 3 C's, and it's an amine every time. So alcohols don't get classified the same as amines. I'm going to write it down right here. Alcohols count number of bonds to alcohol carbon. So it's the alcohol carbon is this one. And it's got an OH on it. This has 1 bond to C. As opposed to another example, these are all examples that are brand new down here. We'll use light pink. Yeah. Down here, we'll go HO bonded to C, bonded to CH3, bonded to C double CH, H, bonded to H. What's the category of alcohol this time? So first of all, which carbon gets turned to green? Because that's the one you need to look at. The one attached to O is the only one you're classifying. Alcohols, you classify this carbon. Amines, you classify the nitrogen directly. Got it? It's a different system. How many bonds does this carbon have to carbon? 2 bonds to carbon makes it a secondary alcohol. Want to see a tertiary while we're here? Why not? CH3, C, CH. Tertiary alcohol. Misleading. Should make this the green C and the alcohol is blue. They all have the O bonded to H, bonded to one C. You don't do the O. Okay, want to see a tertiary amine while we're down here? How about this one? There's your amine. Here it is, CH2, 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 CH3. What kind of an amine is that? You look directly at the nitrogen. Count the bonds to carbon. What do you got? 3. Amine. Amine. All right, that's good. And stop. Oh, we didn't do them all. Up here is an ether. And over here is an ester. What's the difference between ether and an ester? I'm going to highlight what an ester is. COC with a C double O. And I'm going to highlight what an ether is. COC. Do you see any C double bond to O? No C double bond to O. No C double bond to O, not ester. Must be ether. Okay? So read about functional groups definitely this weekend. Read about a lot of things. Try to finish reading chapter 1 this weekend because you got all the way to Wednesday for class, right? No class Monday. Martin Luther King Day, you're going to do good things, right? Help your fellow humans. Yes. And then this over here, this is a Chem 242 functional group. You're not responsible. Chem 242. It's called an imine. It's got a double bond to the nitrogen, okay? So I'm not going to talk much about it. And F is, there's nothing really there. We can say alkene. Why not? Alkene for C double C. Alkyne for C triple C. They're coming up in this course anyway. And when we have, CH3, CH2, CH3, that's an alkane. So when it's just C's and H's, you got 3. You got alkane down here. You got alkene with a double bond. Where's the alkene? Where'd you go? Where'd you go? Right there. And then an alkyne. So a lot of introductory stuff there. A lot going on.